Since 1960, cities across the globe have laid down more than 20,000 kilometers of new urban rail. As this map shows, Europe and Asia have built dense, interconnected networks over the last 6 decades, while the United States footprint consists of isolated corridors. Comparing costs reveals a massive discrepancy. The United States builds a fraction of the transit found in other developed nations, yet per-mile costs in U.S. cities rise high above the capital spent by nations like Italy, Sweden, and Turkey. Researchers at the NYU Marin Institute compiled the Transit Costs Project database to figure out exactly why this gap exists. The data shows that the cost of raw materials and the basic hourly wages of construction workers do not account for this price difference. We will trace these costs through 3 specific bottlenecks. First, legal paralysis. Second, engineering geometry. And third, procurement mandates. To trace exactly how all these costs compound, we can follow the entire life cycle of a modern U.S. transit megaproject. Every major build must navigate 3 distinct choke points: procedural planning, excavation geometry, and equipment procurement. By observing these 3 phases in chronological order, we can identify exactly how discrete policy choices combine to make public transit economically unviable. Phase 1 begins years before any dirt is moved. The primary gatekeeper for federal infrastructure is the National Environmental Policy Act, or NEPA. When Richard Nixon signed NEPA into law in 1970, the intent was for agencies to briefly study the environmental impacts of their actions. But following the 1971 Calvert-Cliffs judicial decision, courts began to enforce NEPA based strictly on procedural compliance. Agencies are judged not on the actual environmental outcomes of a project, but on whether their paperwork proves they considered every possible alternative. This created a practice known as litigation proofing. Federal agencies now overstudy every theoretical impact to avoid having their project halted by a procedural injunction. This defensiveness shows in the physical size of documents. Official guidance recommends an environmental impact statement stay under 150 pages. Today, those reports multiply into stacks thousands of pages long, and a Stanford study shows 28% of these projects still face pre-development litigation. Environmental review frameworks prioritize defense against well-funded stakeholder lawsuits over the rapid deployment of green infrastructure. If a project survives the legal planning gauntlet, it enters Phase 2. Physical civil engineering. The default excavation methodology in the United States relies on the tunnel boring machine. Planners choose these massive drills specifically to keep construction deep underground to avoid surface-level traffic disruption. Drilling the horizontal tunnel itself is relatively efficient. The true financial challenge lies in the stations. This shows a deep bore alignment. Building a station requires excavating a massive vertical volume of earth to connect the street to deep platforms. Contrast this with legacy cut and cover. Digging a shallow trench directly beneath the street lowers excavated material volume and eliminates complex deep cavern engineering. Yet transit agencies frequently ignore existing open geographies. The I-94 highway trench in Minneapolis and St. Paul offers a pre-dug landscape suited for a cheap cut-and-cover subway line, but the option was initially dismissed by the Department of Transportation. The political desire to avoid temporary street disruption forces engineering geometries that jeopardize the financial viability of transit agencies. The final phase involves equipping these tunnels with rolling stock, the actual trains. Here, procurement is governed by Buy America provisions. Federal law mandates the use of domestic manufacturing for transit projects receiving federal capital grants. Because the United States lacks a continuous domestic rail manufacturing base, foreign firms build bespoke transplant factories to fulfill single-city orders. Niskanen data shows European and Asian trains cost under $100,000 per meter, while the U.S. premium exceeds $170,000. This fragmented approach omits global standards like the open gangway, which lets passengers walk between cars. Politicians defend these mandates by arguing that they protect the American working class. However, the data shows that establishing these temporary manufacturing plants costs the public upwards of $1 million for every single job saved. These protectionist laws, designed to secure domestic jobs, ultimately sabotage the core infrastructure required to support a modern American economy. These factors combine into a unified model of dysfunction spanning planning, geometry, and procurement. These inefficiencies compound, amplifying the baseline expenditure into a tenfold increase in cost. This is the result of functional transit economics. Cities like Munich build highly efficient, integrated subway systems because their processes prioritize construction over bureaucratic friction. The current legal and procurement framework makes this cost premium a mathematical certainty. Injecting federal dollars into broken systems cannot achieve reform. The underlying structures themselves must change. Reducing costs requires limiting procedural litigation loops, embracing politically difficult cut-and-cover alignments, and integrating with the global supply chain for rolling stock. Only by addressing these structural bottlenecks can the United States return to building infrastructure rather than simply litigating it.